Dimensional dimensionality reduction. So basically, we have already come across like the number of inputs, like features, variables, columns, everything, parameters, everything. So all this in a given data sets are known as dimensionality. Okay. So the process of reducing these features is called as dimension reduction. Okay. So a data set contains huge number of input features in various cases, which means the predicted modeling task will become more complicated because it is very difficult to visualize or make predictions for the data sets with the number of features or such cases like dimensional reduction techniques are used uh, to reduce wherever it is required. Okay, so it can be defined as it is a way of converting higher dimensions dataset into lesser dimensions dataset, ensuring that it provides similar information. Okay, so again there will be a little drop in accuracy when you are doing a dimensional reduction, but again complexity will be reduced, and also the all the challenges with respect to higher dimensions. So maybe you have sometimes you will have 10-20 features. Okay, so at that scenario it is very difficult, and visualization of data is it can tell us it is almost nearly impossible. So usually we hardly visualize with respect to 2 dimensions or sometimes 3 dimensions. Okay, but if you have so many dimensions, understand the complexity, how much it will be with respect to uh, evaluating the model. Okay, so doing the predictions with respect to the machine learning model. So hence such techniques are used to reduce dimensions, which will provide similar information. Means we'll try to get as much as significant information as required. Okay, so it is commonly used in the fields with high dimensions data. So basically these data can be like such as speech recognition, processing, and bioinformatic, etc. So it can be also used for data visualization and noise reduction, and also for clustering analysis too. Okay, so this is a technique. Okay, it is before applying any of the machine learning algorithms. So that is what we are seeing over here. And again, dimensionally here we have a quick overview of what and all will be used, and we won't be covering up everything. So in this video we'll be going through with respect to a small information about or insight about all the these dimensional reduction techniques. So the first thing is it is divided into feature selection and dimensionality reduction. Okay, so in feature selection, maybe you're missing value ratios, low variance filters, high coloration filter, random forest, backward uh, feature extraction. So everything is feature selection. So again, we'll see in detail. So here we have with respect to dimensional reduction. Components or factor based. So basically a factor analysis, a principal component analysis. So we'll be having a deep dive into principal component analysis in the next in the further video or in the next video itself. And finally independent component analysis, and we have isomap, tsne, and umap. Okay, so those are projection based. So again, before proceeding with respect to benefits, so there is a curse of dimensional, so something like that. So handling the high dimensional data is very difficult in practice. So that's why it is commonly known as curse of dimensionality. So if the dimensions of the input data set increases, any machine learning algorithms or model becomes more complex. Okay, so as the number of features increases, the number of samples also should be increased proportionally, and the chances of overfitting also increases. So I hope everyone remembers the concept of overfit, right? So it is like the accuracy what you are getting like with respect to the testing set and training set. So if the machine is trained in higher dimensions, it becomes morely overfitted and results in poor performance. Okay, so hence whenever you have high dimensions, we have to go with high dimensionality reduction technique. Okay? So what are the benefits of what are the some benefits of applying dimensional reductions techniques to the given data set before training the model or whatever? So basically by reducing the dimensions of the features, the space required to store the data will also get reduced. So for example, if you have 10-15 dimensions, after using this technique, you will end up with only 2 dimensions. So having 15 columns, instead of that you have only 2 columns. So directly it is directly understood that the space to be stored with respect to data storage, and also with respect to the data also, it will be reduced. So instead of 15, you are replacing by just 2 features. Okay. Since there is very less data also, the lesser will be the computational training time. So even less computational training time is required for reduced dimensional features. So implementing on 15 dimensions is um, very time consuming and also compute consuming when compared to working on only 2 dimensions or 3 dimensions. Reduced dimensions of features of the data set helps in visualizing the data quickly. So as I was telling, if you want to visualize the data like 15 dimensions, it is we will not able to visualize that using matplotlib and all. But whereas if you have only 2 dimensions after reducing after using dimensional reduction, so visualization of data will become quite simple and quite easy at this scenario. So hence that is another benefit. And finally it removes the reductant features, so if present. Okay, so taking care of the multi collinearity function. So again all the reductant features will be removed over here. So that is beneficial for us, so that we will be getting higher accuracy. So again we have few disadvantages. So there isn't much, but very few. Okay, so some data might be lost due to dimensional reduction. So that's what I told. So accuracy score, if at all you have a very big complex circuit which is working, and you don't have any time constraint to be met. So at that scenario, you test out with respect to the machine learning model which is trained with all the dimensions, and the machine learning model which is trained with dimension reduction. The machine learning model which is trained with the dimension reduction, so that means less number of features, reduced features. So that will give us like lower accuracy. So that's why this is because there is lost of data. Okay, so lost of maybe not entirely significant data. So you should not have a dimensional reduction in such a way that 15 features down to 2 features will reduce the accuracy from 98 or 99% to 65 or 70%. So usually that is a huge loss. Okay, so at that scenario we are not considering with respect to the significance, or we are losing a whole lot of significant data. But we avoid such things. So again, in the PCA, principal component analysis dimensionality reduction technique, some of the principal components are required to be considered as unknown. Okay, so some of them are required to be considered as unknown. Hence over here again, since they are considered as unknown, again we will be having a lower accuracy. Okay, so these are the only two disadvantages when it comes to find dimensional reduction. And we have the approaches. We'll discuss the approaches for dimensional reduction. So first is feature selection. So again we will go through only few of them. So in this method, the basically in feature selection, the data set the process of selecting the subsets of the relevant features and leaving out the irrelevant features present in the data set. So we'll, maybe out of 15 you are selecting only 2. Okay, so here I'm not telling out of 15 you are reducing it by 2, or first is feature selection, right? So over here you will select only a few of the features which are more significant. Okay, so the first technique, first we will be discussing about 3 methods. So the first method is filter methods. So in this method, the data is filtered, and subset that contains only relevant feature is taken, and some of the common techniques over here used are like correlation, chi-square tech, ANOVA, and also information gain, etc. So again, those who are interested can go ahead understanding those. So again, it depends on your application or the project what you are working on. Okay, so if there is features which can be directly dropped down, so go ahead and directly drop down those features. No need to worry about it. Again, back to the same example which I was telling with respect to the image being like on top and bottom. So those can be considered as features which does not give a significance. So you can just filter out those. And next is a wrapper method. So the wrapper method has the same goal as the filter method. So but here it takes the machine learning model for its evaluation. Okay, so in this method some of the features are fed to machine learning model, and evaluates the performance. Okay, so then based on the performance, decides whether those features are to be like to add those features or remove those to increase the accuracy of the model. Basically, complexity, reduce the complexity and get an appropriate accuracy. So in this the method, there is more accurate filtering. This method is more accurate than the filtering method, but it works like a complex. The work also is a bit complex because you need to feed individual features or a set of features, however you are looking at. So you need to feed that to the machine learning model and get the and evaluate the performance. So based on that only you will be deciding which are the features to be taken and others to be removed. Okay. Again, there are some techniques with respect to wrapper methods too. So those are like forward selection, backward selection, and bidirectional elimination. Okay. And next is embedded methods. So embedded method checks the different training iterations of machine learning models and evaluates the importance of each feature. Some common techniques in the embedded are like LASSO, LASSO, elastic net, and rigid regression. Okay, and so on. So basically, here it is like the different training iterations of the machine learning model and evaluates the importance of the feature. Okay, so that is like embedding the feature to the machine learning model. So it is the name self-explanatory. So feature selection, and next is feature extraction. So this is a much more efficient way. So feature extraction is a process of transforming space containing many dimensions into space with fewer dimensions. Okay, so that is where we are like transforming the complete features itself. Okay, so again this will be taken care of by extraction technique. So this approach is useful when we want to keep the whole information, but use fewer resources while processing the information. Okay, so it's like we want to keep, like, again there will be slight uh, features or slight losses of data or information too, but still it is much more efficient when compared to feature selection. So again it depends on the data set itself. So sometimes feature extraction would take a lot of a bit more compute resources, where feature selection would have done the same exact accuracy, would have given the same thing. So it mainly depends on the type of application we are dealing with. Okay, so how exactly we need to train our machine learning model. So some feature extractions are principal component analysis. Again, we'll have a uh, deep understanding later on in this video and also in the further videos. Linear discriminant analysis. So this is another most commonly used. So we'll see that also. And next we have kernel PCA. So kernel principal component analysis. And finally we have quadratic discriminant analysis. Okay, so all are kind of similar. So again we'll discuss about the more common features. Okay, so most common techniques of dimensional reduction. So basically here with respect to most common techniques in dimension reduction, we have principal component analysis. So let me give a brief insight over here. PCA is a statistical process that converts the observation of correlated features into a set of linear uncorrelated features with the help of orthogonal transformation. So basically it will be getting the it will literally convert the observations or the features of correlated features into set of linear uncorrelated features. Okay, so again it uses orthogonal transformation. Again if you are not familiar with orthogonal transformation, just go back. I think you have to go back and check with respect to the matrices, working on matrices. Okay, so there is something known as orthogonal transformation, and these new transferred features are called as principal components. Okay, so the final features what we get will be named as principal component 1, principal component 2. So it's like PC1, PC2, PC3. So it is one of the popular tools that is used for explanatory data analysis and predicting modeling, predicting models, predictive models. Okay, and PCA works with considering variance of each attribute. Hence, the high attribute shows the good split between the classes, and hence it reduces the dimensions. So some real world applications would be like image processing, again movie recommendation system, optimizing of the power allocation in various communications. So basically, advertisement also will take multiple sources, right? So multiple sources to give you better advertisement. So with respect to AdSense or recommendations. Okay, so based on that, the features also increase. So that's how they can use principal component analysis. So just cut down all these features into a few number of features. So usually two are preferred, and finally we can just deploy on any type of machine learning algorithms. We have come across a lot of machine learning algorithms in our previous videos, supervised, unsupervised. So those can be used like any whichever best fits with respect to the application and analyzed. Okay, so the next common technique used in dimensionality reduction is backward feature elimination. So the backward feature elimination technique is mainly used for developing linear regression or logistic regression models. Okay, so if you're going with this, so when you're working on a linear regression or logistic regression models, you can go with the backward elimination. There are a few steps for reduction, so maybe I'll just give a quick insight about it. So firstly, all n variables of the given data sets are taken into training model. Okay, so you will take all the data set into training model, then perform the model. The performance of the model is checked. After that, you will remove one of the features. So now you will be training the model with we had n features, right? So we will have n minus 1. So again, you will be doing a repetitive steps like for n times. Again, you will compute the performance of the model. Now you will check the uh, we will check the variable that has the smallest or the no change in the performance of the model. Okay, so you will drop down one by one, right, for n times. So you'll check whichever is left out. Okay, so it is like kind of a repetition mode. So same thing, maybe one of the feature is not giving you much significant difference. So maybe your performance like is reduced from 97.8% to 97.5%. So definitely this particular feature does not have much significance. You can just directly eliminate this, and now you will be left out with n minus 1 features. Okay, so maybe you had 10 features at the beginning, and now you have 9 features. And again, now you can repeat the steps until you can get the satisfactory this one. So this is like kind of trial and error. Okay, so basically backward elimination. You are having all the features and you are eliminating them. Okay, so in this technique, the by selecting the optimum performance of the model and maximum tolerable error rate. Okay, so we define the optimum number of features required for the machine learning model. So when you are drastically dropping down with respect to the features, you will just have all those features. So here in backward elimination, you might not end up with 2 or 3 reductions. So it can be more also, 2 or 3 features. Rather, it will be like for 10 on an average, maybe 6 or 5 at least. Okay, and we'll discuss about the next one. So forward selection. So with respect to forward selection, forward feature selection, it's just the inverse of the backward selection process. Even the name is self-explanatory. It means in this technique, we don't eliminate the features. Instead, we will find the best feature that produces the highest number of performance model. So again, the steps will be like we start off with a single feature. Okay, we'll feed the single feature. Then progressively we'll be adding up new features at a time, and then you will be checking with respect to the performance. So all these features will be tested with will be trained on the model again, each feature separately. So then you will pick the best performance, and then you can repeat this step by adding the new feature. So you have the best performance feature first, and then you will try to check with next feature. So you will reach at the point where your accuracy score is quite high and satisfactory for your application. So at that scenario, you can just stop with those number of features, and you can consider only those features. So here we have reduced the dimensions. And next we have missing value ratio. So if a data set has too many missing values, then we just drop those variables. Okay, as such as like they do not carry much useful information, since the model doesn't know how to train, because there is a lot of missing information. So when you have missing information, those particular feature, you don't know how exactly how 100% those information will be used for your predictions. So that's why wherever you have missing values, you will just drop down those features. So again, this will come into real time. Whereas if you are working on a few projects, so don't consider. You can definitely consider with respect to missing value ratios also. But as a beginner, don't start with missing values data set. Go ahead with the data set which has the complete information, and then later on check with that. So you need to tackle this situation one at a time, so that you will be having a robust in the future. Okay, so to perform this, again, missing value ratio, we will just set the threshold level. If the variable has missing values more than the threshold voltage, then we just drop down the feature. Okay, so higher the threshold value, the more efficient the reduction is, but chances are the more loss also. Okay, with respect to the data information. Okay, so that is a missing value, and next we have low variance filters. So again, as same as missing value technique, so the data column which changes in the data has less information. Okay, so maybe you have some kind of data like it is like two or three maximum. Okay, so two or three values are changing with respect to one particular feature. Maybe the values can be 1, 2, 3 itself. So it is either 1, 2, or 3. Whereas in the other features there is drastic change. Or maybe 15, it is varying till 10,000, 14, 100, 500, 687, or maybe 1,500 or 5,489. So all these are the different values. Okay, numerically speaking. So these features, like there are features which will be varying a lot. So again, that definitely gives you a lot of insights about your characteristics, right? But there are some features it is like either 1, 2, 1, 2. Okay, like very low variance. Okay, so here when it comes to low variance, so the data columns or the features with some changes will have very less information. So therefore we can calculate the variance of each variable, and all the data columns with the lower variance can given with a threshold and drop down those because of low variance feature. Okay, so similar to missing value ratio, here we have low variance. Okay, and next we have high correlation or correlation filters. So high correlation refers to the case when two variables approximately have similar information. Okay, so basically, it will be like one feature is in numeric values, and some features similarly another feature has same numeric value with a decimal number. Okay, so maybe 14 and other has 14.25, and if this feature the first feature is varying like 20, and the second feature the same corresponding data set has like 20.1, 20.2. Okay, so just an example. So in this, like there is very approximately same feature. So due to this factor, the high performance of the model can be degradable. Okay. So this correlation between the independent numeric variables gives the calculated value of the correlation coefficients, right? So if the value is higher than the threshold, so we can just remove of the variance. So you can just figure out with respect to correlation variance between all the independent columns, and have a threshold which and all has very high like above the threshold value. So we can remove those features from the data set. So we can consider those variables which has data set will be like a similar, like the other features will give the same information. Okay, so next is random forest. Okay, so basically here we will be converting numeric data into hot encoding, something like that. So random data is a popular and very useful feature selection algorithm in machine learning. This algorithm contains an inbuilt feature importance package. So we do not need to program it separately. So in this technique, we need to generate a large set of trees against the target variable. So we will be having decision tree, right? The algorithm which we have seen. So we just need to we need to generate a large set of trees against the target variable, and with the help of usage statistics of each attribute, we'll find out the subset of the features. Okay, so here random forest algorithms takes only the numeric variables. Okay, so it does not take any other, only numeric data set will be applicable over here. So we need to just convert the input. If at all you have other one, so then you can just convert the input data set into numeric data set by using hot encoding. Okay, so that's what I was telling with respect to hot encoding. Again, if possible, we'll see in with respect to a project with respect to hot encoding. And next we have factor analysis. So we have one more after this. So factor analysis is a technique in which each variable is kept within a group according to the correlation with other variables. Okay, so it means variables within a group can have high correlation between themselves. Okay, so but they have low correlation with variables of other groups. Okay, so high correlation between themselves and between the variables and very low correlation variable with the other groups. Okay, so like we'll try to understand with respect to an example. Okay, so we can have two variables like kind of income and the spending rate. Okay, income rate and the spending rate, or income value versus the spending value. So these two variables have a high correlation. Okay, so it is like when you have high income only, you will be going with high spending. So you will have the option of high spending. With low income, you won't be having the option of high spending. So like likely we will be having high correlation in which which means like people with high income might spend more income, more spending, and it can be vice versa also. Low income might be low spending also. So such variables are put into groups. So the group can also be known as factors. So these factors, the number of factors will be reduced as compared to the original dimensions of the data set. So that is factor analysis. And finally, we have autoencoders. So autoencoders is one of the popular method of the dimensional reduction. Methods. Okay, so which is like kind of we will be seeing type like neural network, so artificial neural network, so that aims to copy the inputs to their outputs. The input is compressed into latent space representation, and the output is occurred using this representation. Okay, so it mainly has two parts, so encoder and a decoder. So the encoder does the encoding technique where it will be doing compressing, okay, from the into the form of a latent space representation, and decoder will be doing the recreation of the output. Okay, so during the input you will be doing encoding process, during output you will be doing the decoding process. So that is auto encoder, which is another commonly used technique. So that's all about detailed information about dimensional reduction. So it is one of the key techniques which will be helping with respect to reduction of computational power, as also timing, and also with respect to the complexity of the machine learning model. So in the next video, we'll see principal component analysis.